The expectation of a random variable is an average of the values that it takes, weighted by the probability that it takes them. For example, if x is the outcome of a weighted die whose probabilities are shown in this table, then the expectation of x is calculated by multiplying the values x takes by the probabilities it takes them and summing up. In general, if m sub x is the probability mass function of x, then the expectation of x is the sum over all values k that x can take of k times m sub x of k. Similarly, if x is continuous with density f sub x, then its expectation is the integral of x times f sub x of x. Probably the most important property of the expectation is linearity, meaning that the expectation of a sum is the sum of the expectations for any random variables, and that the expectation of a constant multiple of a random variable is the constant multiple times the expectation. Another important property is that if x and y are independent, then the expectation of their product is the product of their expectations. Here's a little exercise for practice computing expectations. I roll 3 fair dice, call the outcomes x, y, and z. What is the expectation of the sum squared?